Hello, good afternoon to all of you. I hope all of you are doing well. In today's class, we will be performing comparison between various Motorola processors. In order to facilitate comparison, we have taken into consideration five major Motorola processors, which are MC68000, we have MC68008, then we have MC68010, followed by MC68012, and eventually MC68020. Now, these five Motorola processors are compared, taking into consideration 10 important aspects, which are first one is type, second one is frequency, third one is data lines, fourth one is address lines, fifth one is virtual address range, sixth one is bus control or bus protocol, seventh is clock cycle per bus cycle, eighth is number of data strokes, ninth number of transfer acknowledgement, then we have function code lines, and eventually we have bus arbitration lines. Now, let us try to understand the significance of each of these features in a little detail. Now, type basically refers to the capacity of the microprocessor. So, if I say that the microprocessor is 16-bit microprocessor, it implies it's capable of processing 16-bit of information per unit time. Right? So, that is what capacity of the microprocessor basically tries to refer to. Now, greater the processing ability of the microprocessor, greater will be the strength of the microprocessor. Now, frequency. Frequency basically refers to the operational frequency of the CPU's core. So, microprocessor frequency specifies the operational speed of the CPU's core. Now, it's often measured in hertz. Now, data lines. Data lines are lines that are capable of conveying data from or to a microprocessor. So it's capable of communicating information from the microprocessor or to the microprocessor, right? So data line conveys bits from one device to another device. Now likewise, address lines. Address lines are lines that determines the location of the source or the destination of the data. So this is very much important. So address line determines the location of the source or the destination of the data. So data lines are bidirectional lines, whereas address lines are unidirectional lines. Now virtual address space. Virtual address space basically refers to the address that is available to a process. Okay, right? So virtual address space basically refers to the virtual space that is available to a particular process. Now, bus protocol. Bus protocol, the very purpose of the bus protocol is to enable two brainless devices interact with each other. So this is very much important. So the purpose of bus protocol is to enable two brainless devices communicate with each other by spelling out every step of the process. Now, the bus protocol makes sure that device knows each other's state of affairs when they take the next step. A bus is called asynchronous if the steps of the bus protocol is not guided by a clock signal. So this is very much important. So we can have synchronous or asynchronous interaction between various devices. So here a bus is called as asynchronous if steps of the bus protocol is not guided by a clock signal. Now likewise we have clock cycle per bus cycle. So the bus cycle is the cycle or the time that is required to make a single read or write transaction between the CPU and the external device such as external memory. Again I'll repeat it. Bus cycle is the cycle or the time required to make a single read or write transaction between CPU and external devices such as external memory. Now minimum clock cycle per bus cycle basically refers to how many clock cycles are required for a given bus cycle, right? Okay, so this is very much important for one to understand. So again I'll repeat it. So the bus cycle is cycle at time required to make a single read or write transaction between the CPU and external devices such as external memory. So here minimum clock cycle per bus cycle basically refers to the total time required for a bus cycle. Now, after that, next one is the number of data strokes. So data stroke is a control signal for the data line. So it indicates a valid data during a write cycle. So it indicates valid data during a write. So this is very much important statement that you need to remember, right? So data strobe is the clock signal for the data line, which indicates valid data during a write cycle. Now what we may have is we may have only data strobe, or we may have upper data strobe or lower data strobe. So upper data strobe validates the upper byte of the data bus, whereas lower data strobe validates the lower byte of the data bus. So, for an example, if we have 16 data lines, so upper data strobe basically validates D15 to D8, whereas lower data strobe validates D7 to D0. Right, so you can have a data strobe, or you can have upper data strobe or lower data strobe that are capable of validating the data during the write cycle, either at entirety or in parts, right? Okay, again I'm saying upper data strobe is used in order to validate upper byte of the data bus, that is D15 to D8, whereas lower data strobe is used to validate lower byte of the data bus, that is D7 to D0. Now, number of transfer acknowledgement. Number of transfer acknowledgement, it basically indicates the number of external handshake signals used to cause the termination of a bus cycle. This is very much important. So this is an important signal to the microprocessor from an external device to notify that the data transfer operation is complete. It may be either read or it may be either write. So here number of transfer acknowledgement basically refers to external handshake signal used in order to cause the termination of the bus cycle. Bus cycle may be for read or for write, right? Again, so it's an input signal to the microprocessor from the external device to notify that the data transfer operation is completed or has been completed. Now next one is called as function code line. So function code line is capable of it transmits to the system the processing state of the processor on a bus cycle by bus cycle basis. So it identifies the type of bus activity currently being performed. So that is the purpose of the function code line. So it is capable of transmitting to the system the processing state of the processor on a bus cycle to bus cycle basis, or it tries to identify the type of bus activity currently being performed. Now next one is called as bus arbitration lines. So the bus arbitration technique is used by the processor in order to allow access to any requesting device when the processor is not currently using the bus itself. So for an example, DMA. So this is the purpose of the bus arbitration line. So bus arbitration is a technique that is used by the processor to allow external or to allow access to the buses when when the processor is not actually using the bus itself to any external requesting device. So for an example, we have DMA, that is direct memory access. Now these are the various attributes across which the five microprocessors of Motorola are being compared. So first one is type, then we have frequency, then we have data lines, followed by address lines, then virtual address range, then we have bus protocol, we have clock cycle per bus cycle, then we have number of data strobes, followed by number of transfer acknowledgement, then function code lines, and eventually bus arbitration lines. Now let us try to describe the attributes of the various microprocessor. Now likewise, so MC68000 is 16 oblique 32-bit microprocessor, right? Likewise, 68008 is you have 8-bit, 16-bit, 32 variants of that. MC68010, it has 16 and 32-bit variant. MC68012, it has 16 and 32-bit variant, whereas MC68020 is the 32-bit microprocessor. Now, operational frequency. So MC68000 has 8 megahertz, 12.5 megahertz as operational frequency. MC68008 has 8 megahertz. MC68010 has 12.5 megahertz. MC68012 has 12.5 megahertz. Likewise, MC68020 has 12.5 megahertz, 16.67 megahertz, and 20 megahertz respectively as operational frequency. Now, number of data lines. So MC68000 has 16 data lines, whereas MC68008 has 8 data lines. MC68010 has 16 data lines, MC68012 has 16 data lines, whereas MC68020 has 32 data lines. Likewise, address lines, MC68000 has 24 address lines, MC68008 has 20 oblique 22 address lines, MC68000 10 has 24 address lines, MC68012 has 31 address lines, MC68020 has 32 address lines. Now virtual address range. So for MC68000 it is 16 MB, for MC68008 it is 1 oblique 4 MB, for MC68010 it is 16 MB, for MC68012 it is 2 GB, and for MC68020 it is 4 GB. Now likewise, bus protocol, right? Okay, so it's asynchronous for all the 5 microprocessor, that is starting from MC68000 to MC68020. Now clock cycles per bus cycle. So MC60000, MC60008, MC60010, MC68012 requires 4 clock cycles per bus cycle, whereas MC60020 requires 3 clock cycles per bus cycle. Now likewise, number of data streams. So we have 2 in case of MC68000, we have 1 in case of MC68008, we have 2 in case of MC68010, we have 2 in case of MC68012, and we have 1 in case of MC68020. Now number of transfer acknowledgements. So we require 1 acknowledgement in all the microprocessors other than MC68020, where we require 2 transfer acknowledgements. Now function code lines. So in all the microprocessors we have 3 function code lines. Likewise, bus arbitration lines, we have 3 in case of 68000 MC68000, we have 2 oblique 3 in case of MC68008, we have 3 in case of MC68010, as well as 3 in case of MC68012, as well as MC68020. So these are the cross parameter comparison of the 5 Motorola processors that are MC68000, MC68008, MC68010, MC68012, and MC68020. Now let us try to see the evolution of the various Motorola processors we have. So we have, starting right from 1979, we have first MC68000, that is 8 megahertz, then we have MC68000 12.5 megahertz, then we have MC68008, that's 8 megahertz, then MC68010, which is of 12.5 megahertz, then we have MC68012, which is of 12.5 megahertz, then we have MC68020, which is of 12.5 megahertz, then we have MC68020, again of 16.67 megahertz, and we have MC68020 of 20 megahertz. So the evolution has taken place from 1979 to 1986. So this these are the various Motorola processors that are there. So this particular class was dedicated for comparing various Motorola processors across various attributes like type, frequency, data lines, address lines, virtual address lines, and virtual address range, then bus protocol, clock cycle per bus cycle, number of data streams, number of transfer acknowledgement, function code lines, and bus arbitration lines. So thank you very much. Have a very nice day.